Good morning, my name is Annalisa Milella. I am a researcher at the Institute of Intelligent Industrial Technologies and Systems for Advanced Manufacturing of the National Research Council of Italy. I will present the paper titled 3D Vision-Based Shelf Monitoring System for Intelligent Retail. This work has been carried out in the context of the eShelf research project funded by the Apulia region, Italy. The general objective of the project is the development of an eco-sustainable e-commerce system that integrates a network of retail points of sale into a single virtual marketplace. In this context, it is critical to have an automated online monitoring system of on-shelf stocks. To this end, each store is equipped with an artificial vision system capable of estimating product shelf availability and providing this information in real time to the virtual marketplace. In turn, the marketplace will be able to transmit information on stock data to a mobile app, thus conveying constantly updated information about the actual availability of products to marketplace users. The continuous monitoring of product availability on shelves is especially critical to prevent from frequent out-of-stock events. Efficient Consumer Response Europe reports that stockouts are a central concern for consumers, being the third most important issue for shoppers after the desire for shorter lines and more promotions. Higher check-in frequency of shelves has been recognized as a useful intervention to reduce shelf out-of-stocks. It is the product is available but the shelf has not been refilled yet. However, current human-based survey practices are labor-intensive and do not provide reliable assessment, especially for fast-moving consumer goods, fresh food and products with a due date. In this research, a novel 3D vision-based shelf monitoring approach is proposed. It is based on the use of low-cost RGBD sensors for early detection of out-of-stock events and estimation of on-shelf availability. The system is capable of generating alerts on out-of-stock events, providing up-to-date information for stock inventory and replenishment activities, and updating inventory data for the e-commerce app. The system is intended to continuously survey critical products such as perishable and fresh goods stored in countertop shelves, baskets or crates. In this slide, we can see a picture of a demonstrator of the system installed on the top of a cheese shelf. An Intel RealSense D435 camera is used to provide RGB images and corresponding depth maps of the surveyed scene. A typical sensor output is shown on the right. It should be noticed that in this work, only depth maps are processed for product availability estimation, whereas RGB images are used for visualization purposes only. Let us see in more detail how the system works. This is the overall processing pipeline of the system. The sensor provides a 3D reconstruction of the scene, which is computed based on an infrared stereo processing algorithm running on board the camera and is used for OSA estimation as follows. First, a reference model of the shelf is built. Different regions of interest corresponding to different products on the shelf can be also extracted. Then, for each product, an occupancy grid algorithm is applied to estimate the shelf volume occupied by the product. Such an estimate is retained as a measure of the product availability. The module is integrated in the shelf platform to provide out-of-stocks alerts and OSA estimates online. So the first step includes a procedure to automatically build a model of the shelf support plane. To this end, multiple views of the shelf in the absence of products are required. Then a planar model of the shelf is fit using a maximum likelihood estimation algorithm. Typically, transparent glass or plastic mobile separators may be present on the shelf plane to separate different product categories, as shown in the pictures in this slide. In such a case, a procedure to automatically detect the separators and define different regions of interest, one for each product type, is applied. It uses an edge detection approach to highlight the points corresponding to a significant discontinuity in the depth map, likely due to a separator. A typical result is shown in this picture. Once the shelf model has been built, it is possible to estimate the product on shelf availability. In the context of this work, the OSA level of a given product is defined as the percentage of the shelf volume occupied by product items with respect to the maximum available space. In detail, product volume estimation is performed using a 2.5-dimensional occupancy grid approach. First, points whose distance from the shelf reference plane is higher than a threshold are segmented. Then, a squared 2D grid with size S is fitted to the product point cloud. Each cell I of the grid is assigned a depth value HI corresponding to the average distance of all points of the cell from the shelf reference plane. Then the volume of each cell can be computed as VI equal to S multiplied by S multiplied by HI. The volume Vt occupied by the whole product at a certain observation time T is then estimated as the sum of all cell volumes. Finally, the OSA level of the product is recovered as the percentage of the occupied volume with respect to the maximum available space, Vmax. Vmax can be computed either based on the knowledge of the shelf geometry or directly estimated by the proposed volume estimation approach after complete shelf refill. If the maximum number of products Nmax corresponding to Vmax is known, and under the assumption that all items of the product occupy a similar volume, the number of items per product at time t can also be easily recovered as OSA percentage multiplied by Nmax. The module is integrated in the shelf architecture. Integration is performed based on the TCP/IP stack protocol. Specifically, the 3D-VSM system communicates to the shelf server every 15 minutes all the information related to the current state of the monitor shelves, including store identification number, shelf identification number, product identification number, and product availability estimates. Here we can see the results of experimental tests performed in a real retail store with the depth sensor looking downward at the cheese countertop. In each test, the shelf was gradually refilled starting from an OS condition or emptied after full replenishment. The estimated OSA level was compared with the actual value obtained by manual inspection of the boxes. Results are reported in this slide for 4 different cheese types. A maximum average discrepancy between actual and estimated OSA percentage of about 5 was obtained for the Rodez cheese, which for a maximum number of products Nmax equal to 15 leads to an average error of 0.75, that is less than 1 product over the estimated number of available items. An R-squared coefficient higher than 0.98 was reached in all tests, showing a good agreement between estimated and ground truth OSA values. Similar results were obtained in tests carried out on fruit baskets, showing a maximum average discrepancy of about 2.5 for persimmons, which for a maximum number of available products Nmax of 30 corresponds again to an average error of 0.75, that is less than 1 product, over the estimated number of available items. An R-squared coefficient higher than 0.99 is reached for all tests. Here they come the conclusion. A 3D vision-based shelf monitoring system is proposed. It uses 3D data provided by an Intel RealSense D435 to estimate online the on-shelf availability of products in retail environments. Experimental results show the effectiveness of the proposed approach for online estimation of product on shelf availability in a non-invasive and automatic way. Future work will deal with the development and integration of additional system functionalities, also using RGB information, as well as with the integration on board mobile robots or smart shopping carts to reduce the need for environment infrastructure and increase the overall system flexibility. Thank you for the attention.